Okay, so we're continuing our lessons on factoring, and we have just this one last thing to look at. It's called differences of squares, or difference of squares, and this is a special case of polynomials that we factor. And what we're looking at is the two terms here are perfect squares, right? This is x times x, and this is 9 times 9. Right, so they're perfect squares. Now, I'm going to show you using our method that we've been using that'll still work, and then I'm going to show you some properties of these that will make you can take kind of a shortcut. Okay, so first off, when we were factoring before, we always had trinomials. So I can turn this back into a trinomial simply by adding a 0x, right? Because 0x is not actually adding to it. That has a value of 0. So I didn't change the value, I just changed the way it looked. And then I can use my factoring box, and I know that x squared would go here, negative 81 would go here, and then what went in these two boxes had to add up, right, to be 0x. But they would multiply together to give me the same thing as these two. So I multiply these two together, and I get negative 81x squared. So I know when these two multiply, they're going to give me negative 81x squared. So one of the ways I could figure out what these numbers are is we had our little factor table, or factor tower, whatever you wanted to call it, okay, in which we put the negative 81 down, and we put the 0 at the top, and we said, okay, so what are the factors of 81 that will combine to give me 0? So, 1 times 81, let's see, then 3 times 27, and then 9 times 9, and that's it. Those are my factors. Negative 81, one of the numbers has to be negative. Okay, so I'll just make the second one negative, just to see. Okay, so 1 times negative 81 is negative 81, 3 times negative 27. Right? And now we want to combine them, we want to add them, so 9 plus negative 9 would equal 0. And that's what I was looking for. I wanted it to be 0x. So I put negative 9x and positive 9x, and then I use my factor box here to figure out, well, what do these two have in common? What can I multiply and find as a factor of both? Okay, and that would be x here. And then these two both have a 9 in common. These two both have an x in common, and these two both have a negative 9 in common. Okay, so I multiply those together. X times x gives me x squared, negative 9 times x gives me negative 9x. X times 9 gives me 9x, and negative 9 times positive 9 is negative 81. So what that tells me is the factors here would be x minus 9 and x plus 9. Okay. Now, that's just using the same formula that we've been doing. Another way we could do it, though, is the differences of squares. We could say any number squared minus any other number squared, right, is equal to the square root plus the other square root times the square root minus the other square root. Okay? And we've seen this formula before when we were, it was one of our special cases when we were multiplying. When we had this situation where A would be the same value, B would be the same value, and we have the only difference between the two was the plus and minus signs, we could rewrite it as A squared minus B squared. So we're going the other way on this, and so what that allows us to do is we can take the square root of 25 and we get 5. And we can take the square root of x squared and we get x. So if we're using our formula here, right, 25 would, if we rewrote that, that would be 5 squared minus x squared. So we can say 5 plus x and 5 minus x. Okay, so it's a little bit of a shortcut. But you have to keep, you have to remember it. It is on your formula chart, but you have to remember to apply it. Okay, so let's check number 3. All right, and before we get started, I kind of forgot to mention this on the first set, we always look for our GCF first, right? So here, 4 is in both of these. So 4x squared divided by 4 is x squared, 16 divided by 4 is 4. But these are both perfect squares. So, now that we're still going to have the 4 out front, and we could rewrite this as a squared, or x squared, minus b squared, which would be 2 squared. So if we take that apart, that's x plus 2 times x minus 2. And we just bring our 4 out front. The area of a square is 25x squared minus 1 units squared. What are the dimensions of the square? Okay, so we're looking for, we have a square whose area is 25x squared minus 1. We know that the sides are the same, right? Same length. Okay, so we're looking for these two to multiply together to give us 25x squared minus 1. All right, so I notice 25 is a perfect square. It's 5 times 5. X times x, okay, and 1 is 1 times 1. So this is the difference of perfect squares. So if I could rewrite this as 5x squared minus 1 squared, which means it's equal to 5x plus 1 times 5x minus 1. And that would be the dimensions. But I'm going to argue that this cannot be a square because a square, the sides would be the same, and this would indicate that the sides are not the same because, you know, we've got plus 1 and minus 1. But when we're given the area of a shape, its dimensions are the factors that would multiply to give us that area. So I guess we did it correctly. All right, so you're now going to work on Factoring 5 worksheet, and you may choose to either use the rule or go back and use your boxes. Okay.